Hello students, welcome back to our IIT Foundation classes. I am your chemistry faculty, S. Mohan. So students, grade 6, we started a chapter, Basic Importance of Chemistry, in which we completed first lesson or first synopsis, and in the last class, previous class, we started the second synopsis, right? What was the second synopsis? Did you remember? Very good. So we discussed about some important apparatus which we use in the chemistry lab, right? So chemistry lab, you know that every experiment is done in the lab, right? So to do that experiment, we use various apparatus, and that all apparatus, not all, but important apparatus, what we regularly use, that we discussed yesterday. And I said you to visit your school lab. Did you visit? Good. So students, in the last class, we discussed some common chemistry laboratory apparatus in the test tube holder, test tube stand, round bottom flask and flat bottom flask, and this is a conical flask, right? And beaker, glass rod, and funnel, pipette. So this is a pipette which is used to measure the fixed. So generally it is used for measuring fixed volume of liquid. And burette. So this is a burette, right? Iron stand. So this is an iron stand here. Tripod stand. So this is a tripod stand. Measuring cylinder. So Bunsen burner, watch glass, crystal funnel, china dish. Dropper, separating funnel. This I explained you, which is used to separate the oil and water. And this is stopper and rubber cork and so on. Okay. So students, yesterday we discussed all these things which commonly, regularly we use in the laboratories, right? So what is the use of doing experiments in the lab? Why the scientists perform the experiments? Can you say? So here, due to their experiments only, today we are living a comfortable life. Yes. So what led, means how the chemistry helped us or helping us in our daily life or in industries and everywhere. Okay. So now let us see here. This already we discussed, but once again, the importance of chemistry. The research in chemistry has led to, what are the things? Increase agricultural output and develop the better seeds. As already discussed and I said you, and you also know that day by day the population is increasing, and today our population is number 1 in the world, and it has been reached, crossed 140 crores, right? So now in population, our India is number 1. So as the population increases, the agricultural land is decreasing, because you know that land size is fixed, earth is fixed, it's not increasing. The volume of the earth or the size of the earth, the area of the earth is not increasing, but population is increasing. So due to that, what's happening? The agricultural land is decreasing, right? Now in the less area only, we need to cultivate, means we need to get more crops, right? So here increase in agricultural output and develop better seeds. And next, extract the metals from their ores. You know that iron, copper, zinc regularly we use. So in the construction of houses, generally we use the iron, okay, in the industries, and copper in electrical wires, okay, for conductivity we use the copper wire, and silver, gold used as ornaments. So these all will be extracted from the earth, right? So we don't get these all metals in nature as it is. They get in the form of ores, and we need to extract them, right? So extraction of metals from their ores, mining of petroleum. So see here, this is also very important. So now the total transportation, that is depends on the petrol or petroleum products, petrol, diesel, and so on. All right, and day by day they are getting diminished. The usage of petrol and diesel gradually increasing. So as the demand, okay, to level the demand that much, okay, production is not happening in the petroleum products, right? If we use continuously like this, within hardly 100 to 150 years, then the total petroleum, means petrol and diesel, will be vanished from the earth, right? So that's what scientists are looking for, their alternatives. Like nowadays we are getting like electric cars and solar, right? So of course, so here now mining of petroleum, so take out the petroleum. Okay, so here this is a petroleum. Okay, so from where we can take and develop the alloys. Already we discussed, I think, alloys. So you know that iron get rust. Yes, to avoid the rusting, then what we do? We make the alloy, right? So alloys, and this is about the alloys and new medicines with the help in fighting the diseases. Yes, this also and last 2-3 years back, you might have seen there was a corona. All right, so total 1 year or 1.5 year, all you children and we teachers were at home. Yes, so of course there was online classes were there, but so okay, so to fight with that corona, here the vaccines were discovered, means invented, right? So the medicines, developing the new medicines, make consumer products like plastic. Okay, so like this, making the consumer products. This is all due to the chemistry, students. This is all due to the chemistry. Or only these things? No, so many other things also there. Making products with the help of kitchen, with the help in which is the help in the kitchen and food packing industries. Yes, in the kitchen also you can see nowadays you have pans, Teflon coated pans. You know Teflon coated pans, right? So there's a Teflon. Okay, that's also invention from the chemistry only. Okay, then making soaps, detergents, and other cosmetics materials. Okay, and fuel for space research, paints and varnishes. So paints and varnishes, developing special materials needed in electronics. So these all the things are result of the research in chemistry. Okay, so now once imagine if all these things were not there. Now what I explained you, if all these things were not there, how would have our life? Imagine. Yes, so chemistry plays a very, very important role in our life, right? So students, chemistry is not only a very important topic just to score the marks for you, but it also plays an important role in our daily life also. Remember, so that's the importance of chemistry. Okay, so now let's go to the next topic. Chalo. Here our next topic is matter. Matter. What is matter? Come on students, what is matter? Good. Anything that has a mass and occupy the space is called a matter. Okay, means what? Anything which has a mass, means, and occupy the space is called a matter. For example, okay, so here I have a pen, right? So this stylus, and is this a matter? Yes, of course it's a matter. Why? Because it has some mass, so it has a mass and occupying this space. So if I put this is occupying this much space, so whichever has a mass and occupy the space is a matter. Now for example, here I have a book. Is this comes under matter? Yes, of course this also comes under a matter. Yes, why? Because this also has some mass and occupying some space, so this is a matter. right? Now, for example, you have a glass tumbler. Yeah, there's a glass tumbler. So here, does it comes under mass? Oh, sorry, matter? Yes, of course, this also matter because it also has a mass and occupying some space. Okay, so students, whatever the thing which has a mass and occupy the space is called a matter. So once just you move your head, turn, okay, in your home. So where you are sitting in a school or now, and what are the things you see? If you are sitting in a school, what do you see? You can see the benches, right? Tables, yes. Blackboard, yes. Chalk, yes. Duster, yes. More fan, okay. So all these things you can see in your classroom. Does all this comes under matter? Yes, all these comes under matter. Why? Because all those things has a mass and occupying the space, right? So all this comes under the matter. Okay, now, so whatever you see all around us, they all comes under the matter. Clear? Any doubt? Right. Now I ask you, you wear the dress, okay? So this okay, your dress. I am wearing the blazer. Is it comes under matter? Yes. Now, are we comes under matter? Am I a matter? Yes, I'm also a matter because I has mass and occupying some space. So I'm also a matter. Acha, now I ask you like air. Acha, air. So air, is it a matter? Can you see the air? No. Here I can't see the air. Is this a matter? Think and say. Yes, air is also matter because air has a mass and occupy the space. Yes, air has a mass and occupy the space. Okay, so that's what air is also a matter. Okay, students. So today we are going to discuss about the matter. So students, matter means anything that has a mass and occupy the space. That's a matter. And matter classification. Okay, so matter mainly classified into two ways. Okay, one is based on their physical state. Based on what? Physical state. And the second one is based on chemical composition or chemical properties. Anything you can write. So here I am writing composition. Okay, so this matter are classified in two ways. One is physical state, based on physical state. Second is what? Chemical composition. What is physical state? So physically how it appears and what its state, you know, that it exists in three states. Okay, now see here. So here again it has a three types. Okay, so matter is classified into three types. One are called solids. Second one called liquids. And third one are gases. Right? So like this three types. And here chemical composition. So in the 6th class we are studying about this one only. But okay, if you go to the higher classes in the 7th class or somewhere, we study about this one also. So in the chemical composition, again they are classified into pure substances, okay, and mixtures. And what? Mixtures. Pure substances, again they are classified into two types called elements and compounds. Okay. Mixtures are classified into two types called as a homogeneous and heterogeneous. And homogeneous, of course, it's called as a true solution also. I think we discussed today now solutions. And heterogeneous, again two types are there. One are called colloids and second one called suspensions. Right. So see, oh, very nice chart and so many things. Yeah, is it confusing you? No, it's very simple. Okay, so matter is classified into two types, right? One is based on their physical states. Second, based on their chemical composition, means how it is made up of. Okay, composition means how it is made up of. Okay, so that's the composition. And based on the physical state, they are classified into solids, liquids, and gases. Based on the chemical composition, they are classified into two types, right? Pure substances and mixtures, means like impure. Okay, and pure substance again classified into two types called elements and compounds. And the mixtures are classified again two types: homogeneous mixtures and heterogeneous mixtures. Homogeneous, again It's called as the true solutions and heterogeneous. Two types, colloids and suspensions. Clear, students? So this is a classification. Okay. So in this classification, in the sixth, sorry, you're in sixth class, right? So in the sixth class, we are going to discuss only half part. Means this part we are going to discuss. Okay. And the next year or next class, okay, when I come to the higher classes, then we discuss about this one also. Okay. So any doubt till here? Just once go through this one, just for few seconds. Okay, students. Now let's go. This understood now. So now in this class we are going to discuss only about the based on the physical state. Okay. So let's see now. So here there is some properties all there. So matter. What is matter? Matter means anything that has a mass and occupy the space. Anything that has a mass and occupy the space is called as a matter. And matter can be classified into different types. Okay. So in this the matter is classified. Okay, on the physical properties here, on the physical properties and the states. Okay, in which state? So based on the physical properties of state, the matter is classified into three types. What are they? Solids, liquids and gases. Solids, liquids and gases. So do you know what is solid? Is this pen is what? Is it solid, liquid or gas? Solid. Okay, so this is a solid. If I take the water, okay, I don't have the water now. Okay, if I take the water, water comes under the liquid. Water comes under liquid. And air, of course you can't see, but if you air, so air comes under the gas. I think hope this you know, solids, liquids and gases, right? So solids means what? Which has a definite shape and a definite volume. Okay, which has a definite shape and a definite volume. The meaning is what? Definite shape. So you can see what is the shape of this one. So this is, if you see like this, only this part, this is a rectangle. But if you take into consideration, this is called cuboid. Generally it's cuboid because height is also there. Length, breadth and height. Height is also there. So they have the particular shape is there. Okay. And particular volume also. You know how to calculate the volume. Length into breadth into height. Yes. For example, if you take this book, so it has a length. For example, take 15 centimeters. And breadth, for example, 20 centimeters and a height is some 2 centimeters and so on. So like this, which has a fixed volume, fixed shape, okay, is there. They are called as solids. So here you can see solids have the fixed shape and fixed volume. Solids have the fixed shape and fixed volume. Right. And you know that any matter is made up of a tiny particles called atoms. Do you know this one? Okay. Any matter, whether it's a solids, liquids or gas, it's made up of a tiny particles called atoms. And in the solids, atoms are closely packed. So here you can see atoms are very closely packed. Why? Because there is a strong force of attraction between them. Okay. So they have the strong intermolecular force. Intermolecular force of attraction exists between the molecules. Okay. So that's what they strongly hold with each other. Okay. So here you can see solids have the strong interparticle forces or intermolecular attraction and low kinetic energy. This is a new word I think for you, kinetic energy. Kinetic energy means what? The energy due to the motion is called, simply I am telling. So in a simple way, so the energy possessed by the body due to its motion is called the kinetic energy. But here you think that the energy due to motion is called as a kinetic energy. So here the motion of the particles will be very less in the solids because they are closely packed. You see, you can see here they are closely packed. This is all very close to each other. They are touching with each other, right? So they are very closely packed. So why they are closely packed? Because the force of attraction. Because they have the strong interparticle force of attraction. Okay, the strong force is there. Okay, so that's what they are holding. Okay, now example see solids. Okay, example of solids are what? Iron, ice, etc. Wood. These are all the things. Even this stylus. These are all the examples. Okay, so these are about the solids. Right. Now when you come to the liquids, liquids have the particular shape? No. Yes. So if you have a water, does any water has any particular shape? No. If you take the water in a tumbler, so it occupies the shape of the tumbler. If I take so you see this a glass tumbler is there. For example, if I take the water here, what's the shape of water now? It occupies the shape of the tumbler. Instead of that, if I take the water in a bottle, then what happens? It occupies the space of the, okay, it occupies the space of the bottle. So it is in the shape of bottle. So here liquids occupies the shape of the container, in which container we are taking the water, but they have the fixed volume. Volume is there, volume is fixed. Okay, simply you can say, for example, if your mom asks to get milk from the shop, okay, if you go to the shop and ask the shopkeeper, I want a milk, give me a milk, then immediately what he asks, how much milk you want? Yes or no? How much milk you want? So then what you say? I want half liter, 1 liter, 2 liters, 5 liters, whatever it may be. Okay. So using that word called liters, right? 1 liter or a half liter. So this liter represents the volume. Liter represents the volume. So 1 liter of milk means what? You'll get the 1 liter of milk. Okay, something milk you'll get. And for example, we are traveling, okay, in a bus or train or somewhere, and you want a water. Then what you do? You purchase a water bottle of 1 liter. Yes. So water 1 liter bottle so there. So that is a volume. That's a volume. Now, if you see the quantity, of 1 liter milk and 1 liter of water, does they remain same? Yes, of course, because this also 1 liter, this also 1 liter, quantity is the same, right? So here liquids have the fixed volume. Whether you take the milk, okay, 1 liter, whether you take the water bottle, 1 liter, you are taking the petrol in a bike, 1 liter. So these are fixed. This quantity is fixed. So the meaning is what? Liquids have the fixed volume, but not a fixed shape. They acquire the shape of the container, right? So liquids have a fixed volume, see students, fixed volume, but no fixed shape. Okay. Now, if you come to the force of attraction between them, the force of attraction is little less. The force of attraction is moderate, little less. It's not strong. Okay, moderate. Moderate means what? It's not so strong, it's not so weak, but some force of attraction will be there. And the kinetic energy also little more kinetic energy than the solids. Okay. And examples for the liquids are what? You know that water, milk, oil, etc. Okay. Now, here if you see the gases, gases have neither fixed shape nor fixed volume. Yes, gases do not have the fixed shape and a fixed volume, because gases can occupy the total space available for them. Yes, total space available for them. Means, for example, if I have a perfume, okay, if I spray the perfume here, okay, within seconds it reaches to the corners of this hall, corners of this room. Yes, so that's spreading like this. So it's occupying the total space available for that. Yes or no? Now, for example, if you take the liquid, I am taking the 1 liter bottle and then I am taking only half liter. Does it occupy the total 1 liter bottle? No, it only occupies the half space of the bottle, right? So here it occupies the total entire volume of the room, right? So that's what it do not have the fixed shape and the fixed volume, neither fixed shape nor fixed volume, and they move far away from each other, means they don't have the force of attraction. They don't have the force of attraction. So they have weak, very weak force of attraction and a high kinetic energy. Kinetic energy is, I said, is due to the motion. So they can move far away from each other and they have the lot of kinetic energy. Examples for the air. Example for the gases. This is gases or air, oxygen, hydrogen, etc. Right? So these are the solids, liquids and the gases. So since it's very simple, okay. So here you can see the solids, molecules, atoms are very closely packed. They are very close, touching with each other. Okay, just like these are the close friends. Yes, if I think everyone have friends, okay, you also have some one or two close friends over there, right? So you sit with them and always you hold, okay, them together. You put your hands on two friends and hold together. You sit beside them only. Yes. So wherever you go, you take those two friends also along with you, right? So always they are with you. So because the force of attraction, that's called a friendship. The force of friendship is more among you. So that's what you are very close, right? That is like solids. Okay. Now liquids. Liquids are what? He is also friend. He is also in your class only, but he is not very close to you. Okay. So whenever you come to the class, you say, "Hi, how are you?" That much. But you don't always be with him. Okay. So you maintain some gap, right? So like this, see, they are far from each other. Now these are the gases. Means what? For example, you are in 6th class. Some guys are there in your class, in your school. Those are studying 9th class or 10th class. Okay. Do you mix with them? No. They are moving different classes. You are moving different classes. So there's no force of attraction because he doesn't know you. Okay. So like that. Is this clear? So these are the solids, liquids, and gases. Any doubts, students? Yeah. Okay. So now once you check for 1 minute, and if you have any doubt, we discuss. Yes, students. Finished? Sure. Any doubt? Right. So once again briefly, so matter means anything which has a mass and occupies the space is called as a matter. Matter is classified into three types based on the physical properties: solids, liquids, and gases. Solids like pen, book, everything, and liquids, milk, water, petrol, and gases, air. Right? Okay. Shall we go to the next topic now? Okay. Now next one is a solution. So here, solution. What is solution? Solution can be defined as a homogeneous mixture of two or more substances. What is the solution? A homogeneous mixture of two or more substances is called a solution. Okay, a homogeneous mixture of two or more substances is called a solution. Okay, means what? For example, you say morning. Generally, in the morning when you go to school, your mom say that to have a milk and go. Yes. Do you have a milk? Means you drink the only milk? Do you mix anything in that milk? Yes. Yeah, you mix something. Okay. Sugar. You mix the sugar, and when you mix the sugar, okay, that becomes some sweet. Now the milk becomes sweet. Now it becomes tastier. If you drink only milk, it will not be a tasty. Okay, so what you are doing, you are adding the sugar and then it becomes little sweeter. Okay, so drink, but still no, some students they don't eat sorry, they don't drink only milk and sugar, but along with that they add something in that, right? Horlicks, Boost, Bonvita, something. Okay, so like this, you add something in that. That also you're mixing, and you stir it, and then you drink it. Yes. So now that what you're drinking the milk with the sugar, Bonvita, or Boost, something whatever it may be. So that that is called a solution. What it's called a solution. So solution means what? Solution can be defined as a homogeneous mixture of two or more substances. Maybe sometimes two will be there or more also will be there. Okay, but generally in the chemistry we discuss about the binary solutions. We discuss about what? Binary solution. Binary means what? Only two. Binary means what? Only two. So a solution which contains only two components, which consists of only two components like milk and sugar, or water and salt, something like this, which consists of only two. Okay, so a solution which consists of only two components are called a binary solution. What they are called? Binary solution. Repeat with me. Binary solution. Binary means what? A solution which consists of only two components. Okay, so two components, and in that two components, generally when you take the solution of two components, one component will be relatively more in quantity and other will be less in quantity. Yes or no? Are you following what I am telling? Okay, if you are taking the binary solution, it consists of two components, and in the two components, generally one will be in a more quantity, other will be in some less quantity. Yes or no? Think once. If you are having the milk with the sugar, okay, let's think only milk and sugar. Okay, if you would like to have a cup of milk, now in that you add the sugar. To the cup of milk, do you add the cup of sugar in that? Yes? No, you don't add 1 cup of sugar to 1 cup of milk. Yes or no? So, the meaning is what? Here 1 cup of milk if you would like to have, in that only 1 spoon or 2 spoons of sugar only you will add. Yes? So, milk is cup of and sugar is only 1 or 2 spoons. Correct? So, here that is. Okay, so here generally you take a binary solution. In binary solution, one will be in the large quantity, other will be in the less quantity. Clear? Understood? Chalo, that is about the solution. And in that solution, generally which is in more quantity, that is called a solvent. Students, which is more quantity, that is called a solvent. Solvent means what? Which is more quantity. For example, if you are having the milk and sugar, okay, so that in that which is in more quantity, milk, right? So milk is called the solvent. And which is in less quantity, sugar. Just 1 or 2 spoons of sugar is there. So this is in less quantity. Hence it is called the solute. What is called the solute? Solvent and a solute. So solvent is what? Which is in more quantity. Solute is what? Which is in less quantity. Right? So solvent and a solute. So this is about the solution. Any doubt till here? No. Once again. So solution means what? A homogeneous mixture of 2 or more substances. A homogeneous mixture of 2 or more substances is called solution. And the solution generally we discuss about the binary solutions. Binary means what? Which consists of only two components. One is called solute, one is called solvent. Which is relatively less in quantity is called a solute, which is relatively more in quantity is called a solvent. Okay, like if you take milk and sugar, so milk is called as a solvent and sugar is called as a solute. If you both mix here, then that becomes a solution. In chemistry, what we call it as a solution. And here one word I used. Okay, you might have got that doubt. Okay, what is that? A solution is a homogeneous mixture. I said homogeneous mixture. Homogeneous means what? Homogeneous means what? If we mix the two substances, they should mix uniformly. Uniformly means what? For example, if you are taking 1 cup of milk, in that you are adding 1 spoon of sugar and you stir it till the total sugar dissolves. Okay. Now you taste the milk. In that cup. Okay. So anywhere you can see the taste remains the same. Yes or no? Yes. If you don't dissolve, see here, I am telling you very, very important thing. So you are taking the milk and adding the sugar in the morning and you are trying to stir it, but immediately the bus is coming. For example, your school bus is coming. Then what you do? You don't stir up completely. Or a school bus coming and then immediately you little have it, you drink that milk. But finally, if you see down, okay, there will be a sugar in there. Now you mix it once again you drink. Now this time, the last drop of milk little sweeter than the first one. So don't take that solution. What I am telling you, you take the 1 cup of milk and add 1 spoon of sugar and you stir it till complete sugar dissolves. Okay. Now, if you check the taste anywhere from that milk, that remains the same taste. So, such solutions are called homogeneous solutions. So, solutions are called homogeneous solutions. Okay. So, chalo, now once we see here the solution. Here the homogeneous mixture of, here it should be like two or more substances, okay. So, that is about the definition of the solution. But I said, if it consists of only two components, solute and solvent, then that is called as a binary solution. Okay, students. So, binary solution consists of only two components. One is called solute, other one is called a solvent. So, what is solute? Which is relatively less in quantity is solute, which is relatively large in quantity, that's called as a solvent. Okay. If you have a milk with sugar, then milk is a solvent because cup of milk, and sugar is a solute because it's only 1 spoon or 2 spoon, right? So, a substance dissolved in the liquid. So, in the liquid is what? Milk. Which substance you are dissolving in the milk? Sugar. So, that is a solute. Okay. The liquid which is substance get dissolved. So, in which the sugar is dissolving, that is a milk here. So, milk is called as a solvent. So, simply you can say that which has a more in quantity is called as a solvent, which is less in quantity is called as a solute, right? Now, so see here, sugar is added to water. Now, can you say sugar is added to water? So, which is a, so what is a solvent here and what is a solute? That's all. So, sugar is a solvent. So sugar is a solute as it is less in quantity, and a solvent is a water as it is more in quantity. And here it is uniformly distributed. Just how I told you, everywhere if you see the taste of the milk, that remains the same. Means what here? All the sugar particles are equally distributed among them. Right? Chalo. Now, universal solvent. What is universal solvent? See, universe means okay. So, universal solvent. So, there are so many solvents over there. Like, means generally solvent means what? Here in this case, what you are taking is binary solutions. In that, solvent is liquid. So, a liquid solutions, if you take, so many liquids are there. Okay, like water is there, milk is there, petrol is there, kerosene is there, and benzene is there. So many liquids are there, right? So, in this liquids, which is called as a universal solvent? Water is called as a universal solvent. Why water is called as a universal solvent? Because water has the capacity to dissolve so many things in it. Right? So, that's what water is called as a universal solvent. So, see here, water is a good solvent because it can be dissolved so many things, okay, so many substances in it. So, if you add the sugar, dissolves. If you add the water, dissolves. If you add some glucose, dissolves. So, whatever, most of the things, okay, most of the substances when you add in the water, so those all are dissolves, right? So, water has the capacity to dissolve so many things in it. So, that's what water is called as a universal solvent. What is called a universal solvent, right? So, here when solid dissolves, you see when solid dissolves in liquid, it breaks into tiny particles. Yeah. So, see here, now see this picture. Can you see the picture? So, here first you taking the water, and when adding the salt, you can see the salt. So, you can see the salt. But after stirring, can you see the salt? No. For example, you go to home, okay, and take one glass tumbler like this, and just take some water, and then you take the salt. You can see the salt and add the salt in it. Okay. Now, after adding, you stir it like this. On stirring, what you'll observe? First, when you add the salt, you can see the salt. But if you stir it, then what happens after some time? The total salt disappears. You can't see the salt in this water. Can you see? No. Totally, the salt will be disappear. Yes. So, why the salt is disappeared? What happens to the salt? So, students, when you add the salt in the water and when you stir it, this salt dissociates, means what? Splits, breaks. We can say that breaks. Okay, it breaks into the smaller and tiny particles. Very tinier particles it dissolves, and it breaks into very tiniest particles, and this all uniformly distributed with the mixed with the water. Mixed with the water means what? They uniformly distributed. That means here some terminology we need to use. Okay, so here in the chemistry we need to use some terminologies. So here also we can say that here they dissolves and it dissociates Okay, and it's uniformly distributed throughout the water. The meaning is what? Here, when you add the salt particles, so that breaks into the smaller and smaller and smaller, means tiniest particles, very tiny particles, and these tiny particles mix with the water. Okay, so that happens when you add the salt in the water. So that's the reason we can't see the salt in the water after dissolving. Okay, so this is happens in this one. So students, with this we stop. So today we discussed so many things, and all this you need to first you need to understand, and then read the topics. Okay, and see other in the slides also, everywhere every topic is there, all important matter is here in the slides. So read this topic and try to understand it, try to learn them perfectly. Okay, so that will be helpful you to understand the higher classes concepts, to score the good marks, to achieve the seat, good rank in the JEE Mains and advanced, the NEET also. And above all these things, chemistry is very important in our daily life also. Yes or no? Very good. So hope enjoyed the class, and I think you might have uh, came to know about some new things. You learned some new things, I hope. So good luck. So with this we'll stop. In the next class we meet. Until bye. Take care of yourself.